Hello, everyone. My name is Nick Jennings, and today I'm going to tell you about my project with the UK Home Office working on tackling online child abuse with artificial intelligence. So this is a global issue that has a devastating impact on the lives of its victims. And it's a problem that is growing at an alarming rate. In 1998, there were 3,000 reports of indecent material of children online that were made to the US government. By 2018, this number has exploded to 18 million reports a year. And a big contributing factor to this is the rise of technology. There are more people using the internet than ever before, and the rise of social networks makes it easier than ever to share this material, and encryption allows them to evade detection by law enforcement. Given this, it's imperative that we find new solutions to these problems to help the police, and a part of this solution is artificial intelligence. So how is the government working to tackle this? In 2014, they set up the Child Abuse Image Database, which is a collection of 15 million illegal images that are securely stored and are being added to every 2 months. These are images that could be from anywhere around the world, and they are used by police to aid them in their fight against online child sexual exploitation and abuse. In all of this work, the number one priority is always the safeguarding of those victims. And so that was what my project was focused on. How can artificial intelligence help with this? So what data do we have at our disposal that we can use? Now, don't worry, there isn't any indecent material in this talk. I will be using completely innocuous images. First of all, we have the metadata about the image. This is stuff like the location, the time it was taken, what camera was used, but there are hundreds and hundreds of different potential fields that could be strategically useful that we need to explore. And on the other hand, we have the image itself. So my first step was to conduct an analysis of the metadata that is in Kate. To start with, I interviewed police officers, which allowed me to identify the most strategically useful pieces of information. And my conclusion of my analysis was that they already do an excellent job of making use of this metadata, and there wasn't much scope for artificial intelligence to improve this. And so we move on to the images themselves. Now, artificial intelligence has made great strides in recent years in the field of computer vision, with things like facial matching and object recognition. Now, you might be asking, how does it help us to know that, for example, that in this image, there's a glass there? Well, there are some objects where you can use them to try and locate where your image was taken around the world. Some are associated with being in the United Kingdom, and others aren't. And so the aim of this project was to take one of these objects and use them to classify images as being either in the UK or not. Now, this is strategically sensitive, so I won't be able to tell you what object it was that we chose. So I'm just going to use an illustration. Let's say we see a packet of crisps in an image. We find the object in the image, and then we use the classifier to divide it into two categories, either saying that it's from the UK, here highlighted by this pack of Monster Munch, a beloved crisp in the United Kingdom, but viewed with some suspicion in the rest of the world, or, on the other hand, a non-UK variety. So in order to be able to teach our algorithm to distinguish these, we first need to manually build a training data set of these objects. And so this was done by hand with manual classification. And at the end, I had a data set with 400 images of objects from the UK and 400 that were from outside of the UK. Then the next step was to create the algorithm. And to do this, I would take the images and then feed them into a deep neural network, one that had been pre-trained on millions and millions of images that had got very good at extracting features from those images. However, the neural network did not contain the classification that we needed. And so we needed to add that onto the top. And so once the neural network was trained on this data, it could learn to distinguish between the UK and the non-UK variety. When we tested this on a portion of our data set that the algorithm had never seen before, we were able to reach an accuracy of 95%. But what this means is we have an algorithm that can distinguish between UK and non-UK objects. And this system is now ready to implement on the CADE database. That means that we can link an image to this being as part of the UK, and that then links every image that is also in the same case file as also being in the UK. This allows the police officers to prioritize those images. It not only helps with their welfare in having to scour through fewer images, but fundamentally it will help to locate and protect more children. Thank you.